Hey there, game developers and aspiring game creators. Welcome to our channel. Today we have an exciting video that covers some fundamental aspect of the game development that every game developer should know. Whether you are just starting out or looking to refresh your knowledge, this video is for you. So let's jump right into it. First off, let's talk about the heart of game development, the game engine. According to the Wikipedia, a game engine is defined as a software framework primarily designed for the development of video games and generally includes relevant library and support programs. To understand this, first let's understand why and how game engines comes to life. In early days of game development, games were created without the aid of game engine. Developers had to write all the necessary frameworks themselves. For example, they had to build a renderer to display visual on the screen, create an audio framework to playing sound, and develop a physics framework for simulating relative movements and collisions. The process involved developing the game and all the requirement frameworks or libraries from scratch. However, once developers created this framework for the one game, they realized that they could reuse them for other games with modifications and addition as needed. As a result, companies started to develop and sell collection of these frameworks, giving birth to the concept of game engine. Game engine provide developers with the ready-made sets of tools, libraries and support programs, saving them tons of times and effort in building everything from scratch. One common question that arises is, do I really need a game engine to develop a game? The answer is no, you don't necessarily need one, but using a game engine make a process a whole lot easier. Game engine offers pre-built systems and components, allowing you to focus on the creative aspect of the game design rather than reinventing the wheel. Now, let's move on to what is game flow. One of the key concepts in game development is understanding how game flow works. The game flow can be broken down into three stages: initialization, game loop, and deinitialization. Let's start with the initialization stage. This is a phase where games set up everything it needs to run smoothly. It involves series of important tasks that prepare the game for gameplay. During the initialization stage, the game typically loads and initializes various resources and systems. This includes loading assets such as graphics, audio files, and other media elements. It involves initializing variables, setting up the game's initial stage, and the configuring necessary system like input handling and audio management. The initialization stage ensures that all the requirement components and data are properly prepared before the game starts. It sets the foundation for seamless gaming. Move on from initialization, let's talk about game loop, which is the core of the game flow. The game loop is continuous cycle that handle and update the rendering of the game. It consists of three stages, including initialization, update, and rendering. During the initialization stage, the game loop, the game set up everything it needs to run. This includes tasks like looking for keyboard input or any update since the last game loop. After initialization stage, we move on to the update stage. Here, the game continuously updates the game stage based on player input. It AI calculation, AI physics simulations, and other logic. It's a stage where all the game mechanics come into play. Finally, we have the render stage. In this stage, the game engine takes the updated game state and render it into the screen, creating the visual representation that players see and interact with. It's important to note that this update render cycle happens rapidly in the game loop, ensuring that the game remains interactive and responsive to player actions. Let's touch upon the deinitialization stage. This occurs when game is about to close or exit. It's a phase where any necessary cleanup or finalization tasks are performed, such as saving the game process, releasing the system resources, or gradually terminate the connection in the online game. Let's understand what is delta time. Delta time refers to the time passed since the last frame was rendered. Delta time helps ensure that the game runs smoothly and continuously across different hardware setups, and delta time is usually run in the game loop. Let's touch upon what is frame and frame rate in games. A frame represents individual image or rendered image that appear on the screen. Frame rate, on the other hand, is a number of frames that can be rendered per second. It typically measures in frames per second or FPS. Now, let's quickly cover the rotation value commonly used in the games. There are three rotation values: yaw, pitch, and roll. Yaw represents rotation from left to right or right to left following the horizontal rotation. Pitch refers to the rotation from up to down or down to up, enabling vertical rotation. The finally roll. Roll represents rotation from left to up to right to down, or the right to up to left to down, facilitating diagonal rotation. And that's it. You now have solid understanding of game engine, the game flow, the game loop, delta time, frame and frame rate, and rotation values commonly used in games. I hope you found this video informative and insightful. If you have any more questions about the game engine or other topic related to game development, feel free to leave a comment below. Don't forget to like this video and subscribe to our channel for more exciting content. Thank you for watching and see you in the next video.